This is Titanoboa. It is 13 meters long and it weighs about as much as a small car. Its body is so wide that the man who described it reached for his office doorway to explain it. How did a snake grow as long as a bus? And why has nothing come close since? At least 28 lie in the same rock. To understand how a snake could reach the length of a bus, we must travel back 60 million years to a river in what is now northern Colombia. But the road there does not begin in the Paleocene. It begins in 1994, in a place that could not look less like a rainforest. A geologist walks across the floor of an open pit in La Guajira. The ground is gray, cut into terraces, and there is no shade anywhere. Behind him, the pit walls step down in stages, wide enough that the trucks on the lowest level look like insects. He picks up something heavy and dark, turns it over, and decides it is a piece of petrified wood. He carries it back to the mine office, and someone puts it in a display case. It stays there for 9 years. People walk past it every working day. It is labeled, cataloged, and completely wrong. The place he was standing in is the largest open-cast coal operation on Earth. Its excavators work into a rock formation 800 meters thick, laid down between 60 and 58 million years ago. 2.5 times the height of the Eiffel Tower, in mud, sand, and compressed swamp. Nobody had come there looking for fossils. The company was looking for coal, and every black seam in that wall was once living tissue. Leaves, trunks, roots, standing in water, buried before they could rot. The coal was the fossil. So what turned a mislabeled branch into the largest snake ever described? A student looking for leaves. In 2003, a geology student found something else in that pit. Not fragments. Whole leaves with their veins still in them. He showed them to Carlos Jaramillo, and Jaramillo brought in Scott Wing of the Smithsonian, who studies Paleocene plants. Wing walked through the mine office, saw the object in the display case, and photographed it. He sent the photograph to Jonathan Block at the Florida Museum of Natural History. Block looked at it and recognized it's something nobody in that building had. It was not wood. It was the jaw of an extinct crocodile. The following year, a team began working an abandoned pit called La Puente. What came out of La Puente was not a fossil. It was a population. Vertebrae and ribs from more than 24 separate snakes, recovered from mudstone the color of ash over a series of field seasons, and every one of those animals was enormous. Laid beside the same bone from a 5-meter anaconda, they did not look like they belonged to the same kind of creature. Not a larger version of it, a different order of thing. That is the detail that changes the question. One giant is an accident of biology. A population of giants is a fact about the world they lived in, and it means the conditions, not the animal, are what need explaining. Jason Head, the paper's senior author, was asked how wide the living animal would have been. He answered by describing his own office door. If the snake were coming down the corridor to eat him, it would have to squeeze through that door to get in. Jonathan Block put it more simply. Realities, he said, has exceeded the fantasies of Hollywood. He was not being careless. He had spent his career on Paleocene mammals, animals you can hold in one hand. The reconstructed length was about 13 meters. Longer than the bus that carries the miners into the pit each morning, and heavier than the car most of them drive home. So what kind of world builds a snake that size? The rock, the bones, came out of answers first, and it answers with a temperature. The temperature is not written in the rock. It is written in the animal. Midday on the floodplain. The water is the color of strong tea, and it barely moves. Palms stand in it up to their trunks, and between them the air is completely still. There is no dry season worth the name here, and no cold season at all. Nothing casts a shadow worth standing in. And this is a largely ice-free planet. The icehouse world, the one with permanent caps at both ends, is still more than 20 million years away. There is a rule about cold-blooded animals on land that sounds too simple to be useful, and turns out to be one of the more reliable numbers in the field. A snake, a lizard, a beetle does not make its own heat. Its metabolism runs at whatever speed the surrounding air permits. And the larger the animal, the slower that metabolism runs per kilogram of body. Put those two facts together and a limit appears. For any cold-blooded lineage, at any given temperature, there is a maximum size. A point past which the body is simply too large to keep itself running. This is not a theory about extinct animals. It is measurable today in living ones with a tape measure. Makarieva and colleagues measured where that limit sits. Across 24 groups of land-living cold-blooded animals, from the tropics to the poles, the largest member of a group turns out to be 2 to 3 times shorter for every 10 degrees Celsius of cooling. Run it the other way. Raise the temperature 10 degrees, and the longest animal a lineage can build roughly doubles. So how warm does a 13-meter snake need its world to be? In 2009, Jason Head and his colleagues ran that equation backwards to find out. They had a snake of known length. They wanted the temperature that permitted it. The number they published was a mean annual temperature of 30 to 34 degrees Celsius. about 91 degrees Fahrenheit. Roughly 4 to 7 degrees above the same latitudes today. Not a summer peak. An average across every day and every night of the year. The plants in the same mine were asked the same question, and they did not give the same answer. More than 2,000 fossil leaves have come out of that rock, enough to fill a filing cabinet, and they describe a forest 3 to 5 degrees hotter than a modern rainforest, under more than 2.5 meters of rain a year, deeper than a person is tall, falling every 12 months. The leaves are a separate witness. They were never measured against any snake. Hot, undeniably hot, but 3 to 5 degrees is the bottom of what the snake demanded. Not the top. Hold on to that gap. It becomes the whole case later. Because here is what the temperature does not do. It does not build a snake. Heat only removes a ceiling. It grants permission. What grew into the space that permission opened was not some new kind of creature. It was a boid, the family that still holds the boas and the anacondas, whose living members are South American to this day. And permission has been granted since. There are rivers on this planet right now, sitting in warm, wet, unbroken tropical air. The longest snake ever confirmed alive, anywhere on it, captivity included, reached just over 7.5 meters. Not a fossil, a living animal measured with a tape. So if the heat only opened a door, what paid for the walk through it? The answer is in the rivers, and it is not what anyone expected to find. What the rivers held was not a bigger version of what everyone imagined. A channel under the canopy, the water heavy with silt and moving slowly. Nothing breaks the surface except one flat shape, about the size of a dinner plate, holding absolutely still. It is the top of a head. The eyes and the nostrils sit on the upper surface of it, so the animal can see and breathe while the rest of it stays out of sight. It has been in that position for a long time. So what did that head look like? For years, nobody could say. Snake skeletons are unhelpful. There is no armor, no horns, no fused shell holding the animal together. When a snake dies, its skull comes apart into a scatter of thin, separate bones, most of them no thicker than a fingernail, and they almost never survive together. What survives is vertebrae. Then later field seasons at La Puente produced the rest, upper jaw bones. A palate bone, the quadrate, which is the hinge that lets a snake's jaw swing wide, a lower jaw. The first cranial material ever recovered for the species. So what was this animal eating? Not what anyone had assumed. Everyone pictures a 13-meter constrictor as a crusher, something that takes large mammals, wraps them, and breaks them. The skull says no. The tooth counts are high, along the margins of the jaw and across the palate as well. The quadrate sits at a low angle, and the teeth themselves are only weakly anchored into the bone. Small teeth, loosely set. A great many of them. That is not the anatomy of an animal that breaks bones. It is the anatomy of an animal that holds something slippery and does not let go. It was a fish eater, which is exactly what the rest of the deposit supports. The same beds that hold the snake hold large lungfish and large bony-tongued fishes. Popular estimates put some of those lungfish at around 2 meters, 2 or 3 times the size of their surviving Amazon relatives. A lungfish as long as a doorway is tall. And in snakes, that matters far more than it sounds. A 13-year study of wild pythons in tropical Australia found that how much prey an individual gets early in life sets its growth rate for the whole of the rest of that life. Not its size that season, its trajectory. In a snake, a good childhood is not a memory. It is a measurement carried in the body permanently. The neighbors fill in the rest of the menu and the rest of the danger. Sarajonisukis was a dirosaurid, one of a family of long-snouted crocodile relatives, and at roughly 2 meters, it is the smallest of them known. Its fossils turn up beside the snakes. A crocodile the length of a sofa in the same water. And then Carbonemys, a side-necked turtle with a shell 172 centimeters long and a skull 24 centimeters across, carrying jaws that could crush small crocodiles. A turtle the size of a car bonnet. This next part is inference rather than evidence. A shell that wide is hard to imagine passing down any throat, and an animal with that bite was not waiting to be eaten. So cocalaries were not the constraint. The rivers were stocked, the growth rule was permissive, and the animal had a skull built to exploit both. Which leaves the problem that food cannot solve. How do you carry a ton of animal with no legs to carry it on? The rock the bones are sitting in has already answered that, and for a while nobody noticed. The bones were not found in forest soil. They were found in a river. If you stood on that bank, the first thing to reach you would not be the sight of the animal. It would be the sound. Not a hiss, and not movement through undergrowth. A displacement. The noise of a large volume of water being pushed out of the way by something that has decided to go somewhere. And then, further out, a section of the surface would lift slightly and travel, and you would not be able to work out where the animal ended. You would hear it long before you had anything to look at. The modeled mass is about 1,135 kilograms, about the weight of a small car. Consider what that means for a body with no legs in it. A car puts its weight onto 4 points, each one engineered for the load. A snake puts its weight along its entire length onto whatever it happens to be lying on, through a structure that also has to bend. There is no part of that arrangement designed to hold weight off the ground. And the structure is mostly joints. A human spine has 33 vertebrae. A full Titanoboa skeleton likely carried more than 250. Every one of them is a place where a ton of body can fail under its own weight. So how does an animal like that avoid being crushed by itself? The answer had been sitting in the sediment the whole time. Cerrejón was not a forest floor. The snake's bones sit in river channel deposits, laid down across a tropical floodplain that faced the sea. Sand and mud dropped by moving water. Nobody had to infer the habitat. The rock recorded it. The animal is preserved in the place it lived, and the place it lived was water. Water carries mass. That is not a subtlety of physiology. It is simple physics, and it is why the heaviest snakes alive spend their lives submerged rather than walking around. Floating a body removes the structural bill for it. On land, a ton of snake is a problem in engineering. In a river, a ton of snake is neutral. The pattern holds across living snakes without much exception. The heavy ones are the wet ones. And it changes what the animal is for. A body that heavy on land is a liability to be dragged. The same body in water is a weapon that costs almost nothing to move. Ambush does not require speed. It requires stillness, mass, and the ability to hold a position for hours without effort. The river was not where this animal ended up. It is the reason the animal was possible. And there is a second consequence of that mass, which will matter enormously later. A body that large heats and cools slowly. It carries thermal inertia. 3 researchers, Denny, Lockwood, and Somero, would later press exactly this point. An animal of that size does not simply take the temperature of its surroundings. It moves between sun, shade, and water, and it holds whatever heat it has. To some extent, an animal that big makes its own climate. So, the water answers the engineering. It does not answer the history. Rivers of exactly that kind still run across the same continent. Warm all year, silt-heavy, full of fish. Nothing about them forbids a larger snake. The water is there, the fish are there, the heat is there. And the green anacondas hunting those rivers are the same family, on the same landmass, under the same sun. Adult females average between 3 and 5 meters. Not because anything is stopping them. There is simply nothing pushing them past it. Which is the real question underneath this whole case? What did that world have that this one does not? So what did that world have? Start with what it had lost. 66 million years ago, the Cretaceous ends. Picture the aftermath not as fire but as absence. Whatever is still alive out there is small, and there is a very great deal of unoccupied space. Among lizards and snakes, the bill for that ending came to 83% of species. 5 in every 6 gone. And now the part that inverts this whole chapter. You would expect the survivors of a global catastrophe to be the tough ones, the big ones, the armored ones. They were not. In that extinction, survival was associated with small body size, which is worth sitting with. The reason a giant became possible at Cerrejón is not that giants are good at surviving, it is the opposite. The extinction had specifically removed the large animals and specifically spared the small ones, and it was out of that pruned, shrunken, unpromising stock that the largest snake in the history of the planet was built. Every snake alive today descends from that handful of surviving lineages. Every python, every viper, every anaconda, every grass snake in every garden in Europe. That is worth stating precisely. There is no lineage of snakes anywhere on Earth that did not pass through the 66 million year filter. Everything that slithers today is descended from a survivor of that one event. And the recovery was slow. Squamate diversity, meaning the lizards and the snakes counted together, did not approach Cretaceous levels again for something like 10 million years. 10 million years is not a pause. It is long enough for whole families of animals to appear, spread, and specialize. And for the whole of it, the world was running below capacity. Fewer competitors, fewer predators, fewer things already occupying the roles a growing animal might want. Now place Cerrejón on that timeline. The beds there begin about 6 million years after the boundary, roughly twice as long as the genus Homo has existed, and no longer than that. Which means this animal does not appear after the recovery. It appears in the middle of it. And that is a stranger place to find it than it sounds. The largest snake in the history of the planet is not the product of a mature, crowded, fully rebuilt ecosystem. It is the product of a half-finished one, in the gap before everything else caught up. Does the forest agree with that timing? It does. The Cerrejón flora holds fewer plant species than a modern Amazon forest covering the same ground. The founding families are all present. The diversity is not. Which is a strange thing to be able to say about a rainforest. It was already recognizably the Amazon in its parts, and not yet the Amazon in its numbers. A cast assembled, and the crowd not yet arrived. So here is what the empty throne explains and what it does not. It explains how a snake could hold that role at all. With 5 in every 6 squamate species erased, with the survivors small, and with the recovery still running, the top of a river food web was simply available. A snake took it. Nothing had to be outcompeted. The position was unoccupied. But it does not explain the size. Vacancy is an invitation. It is not an instruction. Nothing about an empty niche says 13 meters, and the animal that accepted the invitation had no special equipment for the job. It was a boid, the same family as the anacondas, a local lineage working with local parts. An open door is not a journey. What held that door open long enough for something to walk 13 meters through it? It held open for 2 million years. Watch the same square of ground for that whole span, compressed. Mud settles. Leaves fall and are covered before they can rot. Peat builds, compacts, and turns into something closer to stone. And the season never changes. Not once, not for a year, not for 1,000 years, not for 2 million of them. That continuity is what the rock actually records, and it is easy to miss because it is so undramatic. 2 million years is the boring part of this story, and also the load-bearing one. Catastrophes leave obvious marks. Stability leaves almost none, which is why it is the last thing anyone looks for, and often the thing that explains the most. 800 meters of sediment is not 800 meters of event. It is the absence of events. Nothing in that column marks a freeze or a long drought or a reorganization of the landscape. Layer after layer of the same coastal swamp, dated by its pollen across a window from 60 to 58 million years ago. Every meter of it laid down under the same sky. And the same forest stands in it throughout. At the 58 million year horizon, the plant families are already the modern set. Palms, legumes, laurels, mallows, aroids, moonseeds, the founding cast of the Neotropics holding station. The climate holds with them. The same warmth the leaves recorded, the same rainfall, with no interruption long enough to leave a mark in the rock. But why should duration matter at all? If an animal reaches its adult size and stops, then 100 stable years and 100,000 stable years produce exactly the same snake. Because it does not stop. Snakes have what biologists call indeterminate growth. There is no adult size. There is no point at which the body is finished. Growth slows after maturity, sometimes almost to nothing, but it does not switch off. A snake that lives 40 years is longer than the same snake at 20, for no other reason than that it has been alive longer, which means length, in a snake, is partly a record of time survived. And the python study supplied the rest. How much food arrives early sets how fast that record accumulates across the whole of the animal's life. Put those two facts against 2 million years of unbroken warmth and unbroken food, and the outcome stops being surprising. It becomes close to predictable. Conditions that stable do not produce one giant. They produce a size class, which is exactly what La Puente shows, not one exceptional animal that happened to outlive its cohort. A whole population of them in the same rock. So the case now stands at 5 partial answers. 4 of them rest on evidence you could physically hold. Teeth, river sand, pollen, the column itself. The 5th rests on a calculation. The figure every account of this animal leads with, the one in the low 30s Celsius, was never measured. It was derived, and the thing it was derived from was the snake itself, which is a circle if you look at it directly. The animal is used to establish the climate, and the climate is then used to explain the animal. And what if that number is wrong? 3 separate teams thought exactly that, and they said so in print within months. They said it in print, and to understand why, you have to look at what the original claim was actually built out of. 2009. A tray of vertebrae on a bench, a column of measurements beside it, and an equation. Nobody has ever seen this animal. Nobody has seen a photograph, a footprint, a shed skin, or a set of gut contents. There is no soft tissue, and there is no complete skeleton. Every claim in this case so far came out of that column of numbers. So it is worth being precise about where 13 meters comes from. You measure the width of a fossil vertebra. You measure the same bone in living boas and pythons, whose total length you already know. You establish the relationship between the two across those living animals, and then you apply it to the fossil. The relationship is not a guess. It holds tightly enough across living snakes to be genuinely useful. And doing it across bones from more than 24 individuals gives you a distribution rather than a single number. That is a good method. It is also, unavoidably, a model. Nobody laid a tape along this animal. The number is an output, and if the length is an output, then so is everything drawn downstream of it, the mass. The temperature, the reconstructed world. So how hard did anyone push on that? Harder than almost any single fossil claim of its decade. 3 separate challenges, in the same journal, within months of the original. The first came from Snyderman, and it went after the sampling. The argument runs like this. The method takes the largest reptile in a fossil assemblage and treats it as the biological maximum for that climate. But fossil assemblages are not neutral samples of what lived somewhere. Preservation favors some animals over others. Big bones survive. Small ones often do not. Some habitats fossilize and some never do. Which means the largest animal in a deposit might be telling you about the deposit rather than about the climate. It is a sampling objection. Sampling objections are rarely glamorous and often correct. The second came from Makarieva and colleagues, and it went after the arithmetic. This is the same group whose temperature rule had made the original inference possible in the first place, which gives the objection a certain weight. Their point was technical and decisive. The calculation uses a metabolic scaling exponent, a number describing how metabolic rate changes with body size. The original had used a dendral value. Makarieva's team argued that Boyd snakes have their own, and that it is 0.17. Rerun with that exponent and the claimed warming halves. Not 4 to 7 degrees above modern, roughly 2 to 4. A twofold overestimate identified by the people who wrote the rule. So what did the third challenge do that the first two had not? It came from Denny, Lockwood, and Somero, and it went after the instrument itself. They had already established the physics. A body of that mass has enormous thermal inertia and can move between sun, shade, and deep water at will. Here is what that does to the method. A paleothermometer only works if the instrument passively takes the temperature of its surroundings. A small lizard does that. A 1-ton animal in a river does not. It buffers, it chooses, it holds heat overnight. An animal that regulates its own body temperature cannot report the temperature of the room it is standing in. Head and colleagues replied in the same volume, defending the model's accuracy for the longest known snakes. 4 pieces of writing, 1 journal, 1 year, and no new bones on either side. So where does that leave the temperature? Look at where the recalculated figure landed, roughly 2 to 4 degrees above modern. Now look back at the leaves, more than 2,000 of them, giving 3 to 5 degrees. Those two ranges are not identical, but they overlap, and they overlap in exactly the place where the snake's contribution has been removed. The two methods converge as the animal is taken out of the calculation. Which is the real finding here, and it is more interesting than a scandal. The fossil plants said the tropics were hot. The snake said they were hotter. Strip the snake out, and the forest is still hot. What vanishes is only the extra degrees, the ones that came from the animal. So the verdict has to separate two things that had been traveling together. Wounded. The specific claim that this animal proves a 30 to 34 degree equator. That claim was contested from 3 directions in a single volume, and its central figure was halved by the very people who had supplied its underlying rule. Untouched. The animal. The vertebrae are physical objects in a museum drawer in Florida. Set the equivalent bone from a living anaconda beside one of them, and it looks like a scale model. No equation is required to see that. And the honest complication is not that the snake turned out to be small. It is that even the describers of a later giant snake concede openly that which equation you choose moves the answer by whole meters. The uncertainty runs in both directions, which is not a debunking. It is a widening of the error bar, a snake that might have been 12 meters and might have been 15. The thermometer broke. The snake stayed. Which leaves the case standing where it began, minus its most quoted answer. So what is left to explain the size and the silence that followed it? Take the second half of that first. The question again, unchanged. How did a snake grow as long as a bus, and why has nothing come close since? The second half of that question contains a false premise, and the proof it arrived in 2024. In 2024, a description was published of 27 vertebrae recovered from the Panandro, lignite mine in Gujarat, in western India. A lignite mine again. Another pit dug for fuel, another animal nobody was looking for. It was named Vasuki indicus. Its estimated length is 11 to 15 meters, which is comparable to the Colombian animal, and by some estimates larger. Its age is about 47 million years, roughly 11 million years after the last Cerrejón beds were laid down. It happened twice. And it happened in a cooler place by a different method. Vasuki's describers reconstruct a mean annual temperature of about 27 to 29 degrees Celsius for its habitat. Warm, but below the range the Colombian animal was supposed to require. And they read it as a slow-moving ambush predator in a back-swamp marsh, subduing prey by constriction in the manner of a modern anaconda, not a river fish specialist. A different animal, in a different setting, doing a different job at the same length. Two giants, two different thermostats. Then comes the third one. And the ordering matters. Gigantophis, from Egypt at about 40 million years ago. It was described in 9901 and held the title of largest snake ever found for 108 years until the Colombian animal took it in 2009. A later reanalysis then cut Gigantophis itself to roughly 7 meters. So the sequence reads like this: 13 meters in Colombia, 11 to 15 in India, and then 7 million years after that, roughly 7 meters in Egypt. The first two are comparable. It is the third that carries the signal. The window is still open at 40 million years ago, and the largest thing coming out of it is half the size. So, if that size was still available at 40 million years ago, what took it away? Not the obvious culprit. Around 56 million years ago, global temperatures jumped several degrees in a geologically brief interval, and the tropics were reorganized. It is tempting to make that the end of the story. It is not. Bus-length snakes were still appearing 9 million years after that event, and large snakes were still around 7 million years after that again. The window survives the heat spike comfortably. So what does close it? Not an event at all. A change of state, and it has a date. Around 34 million years ago, atmospheric carbon dioxide falls steeply. The first great ice sheet forms on Antarctica, and the largely ice-free greenhouse world that had been running since long before Titanoboa comes to an end. 24 million years after the Sarahan swamps, the kind of world they belonged to stops existing. The planet moves from greenhouse to icehouse, and it does not move back. Snakes diversify again on the far side of that line, into a colder and more seasonal world, and the lineages that do well there are built for a different planet. And everything since has lived under a lower ceiling. Nothing measured alive, in captivity, or in a river has reached even 3/5 of the length that came out of La Puente. Two animals of comparable length, 11 million years apart. Then a last large snake at roughly half their size. Then, in the 40 million years since that one, nothing has come close. So the answer was never a single cause. It is a sequence, and by 40 million years ago, the sequence was already producing less. Which link did the ice take? Not the water. What did both giants actually have in common? Start there, because it is the shorter list. Three things. A tropical world warm enough, year in and year out, that the ceiling on cold-blooded body length sat high. Standing water permanent enough to carry a mass no ribcage could, a river floodplain in Colombia, a back swamp marsh in India. In both cases, a body that never had to hold itself up. And a kind of animal with no adult size, so that every additional decade of survival converted directly into additional length, warmth, water, and a body that never stops growing. Colombia had all three. India had all three. Then there is the Colombian surcharge, and this is where the chain becomes a chain rather than a list. An extinction removed 5 in every 6 species of lizard and snake, and it removed the large ones preferentially. That left the survivors small. Small survivors in an emptied world meant no established competitor at the top of a river food web. No competitor meant the role was open to whichever lineage grew into it. And the recovery ran for roughly 10 million years, which is more than 3 times as long as our own genus has existed, so the role stayed open for an almost absurd length of time. Meanwhile, the rivers were carrying lungfish 2 meters long, and one lineage rebuilt its skull into a trap for exactly that, which turned an abundant food source into growth. And growth, in a body that has no finish line, given 2 million years of unbroken warmth, has nowhere to stop. Every link there hands off to the next. Take out the extinction, and the throne is occupied. Take out the fish and the growth stalls. Take out the 2 million years, and nothing has time to compound. Possibly, on top of all of that, an equator hotter than any since. Possibly. That was the one claim the arithmetic would not support. India had none of the surcharge. Different family, different continent, different habitat, a constrictor rather than a fish specialist, no post-extinction vacancy, and a cooler thermostat. It reached the same length by a completely different road, which tells you the size was never one recipe. It was a threshold, and there was more than one way over it. So which link did the ice take? Not the water. Rivers and swamps of that kind still exist. Not the growth rule either. Every snake alive still obeys it and always will. What 34 million years ago removed was the first link, and the widest, a planet warm enough, in enough places, for long enough. When the ice sheets arrived, the ceiling that temperature sets came down with them, and the snakes that flourished afterwards were the ones adapted to a colder and more divided world. And here is where honesty is more useful than a tidy ending. That does not finish the account. Vesuvia reached its length at 27 to 29 degrees, which is not dramatically above the tropics today. Temperature alone cannot be the whole gate. What no warm river on Earth has offered since is the rest of the combination, all at the same time. The vacancy, the prey, and above all the time, an uninterrupted stretch long enough for an animal that never stops growing to simply keep going. That is the answer, not a cause. A coincidence of conditions held still for long enough to matter. And perhaps the harder question is not the one we started with. Rivers of the same kind still run across the same continent. They hold the same family of snake under the same sun. What comes out of them now averages 3 to 5 meters. The planet did not lose the ability to build something enormous. It lost the conditions, and it lost them so long ago that we have no memory of them at all. Which means the strangest thing in this story may not be the animal in the Colombian coal. It may be that we look at a 5-meter snake and call it a monster. From Mystery Origins. If you want more of the deep past, reconstructed from the evidence that survived it, subscribe